Hi there, welcome. This is a presentation to talk about FloodAdapt. The purpose of FloodAdapt is really about accelerating flood adaptation planning. So to jump off, I want to lay the context of how FloodAdapt came to be. So a lot of communities are planning for the future. We know there are a lot of changes up ahead, and decisions need to be made today despite all the uncertainty there is in the future. And a lot of this uncertainty is coming from different drivers of risk. So these can be climate related, like rising sea levels, more frequent tropical cyclones or hurricanes, and changes in precipitation patterns, heavier rainfall or more frequent rainfall. And they can also be socioeconomic changes. So population growth is something that's being experienced in many urban communities, and also economic growth. And all of these changes are having an influence on the flood risk in your community. And the question is, what is the system response to all of these different changes? How is your flood risk changing under these changing conditions? And also, how is it changing in response to the kind of actions you can take in your community? So the answer to these questions is really what motivated FloodAdapt. The idea is that the modeling you need to do to answer these questions needs to be easier, faster, and it needs to be more accessible to the people who are asking these questions and need this information. So this is what stimulated a collaboration with the Department of Homeland Security, Science and Technology Directorate, and Deltares, together with stakeholders who have helped steer the development and bring in the end user perspective to help make this a tool that people really can use and want to use. So what I want to do now is just give you a high level overview of what FloodAdapt is. We've laid the context why it's needed. Here's a little understanding of how it's designed. So the idea of FloodAdapt is that community questions are central to the design. So questions about how long a certain mitigation measure will be effective, questions about the future. What if projections about the future are different than we thought? What's the sensitivity of that? Questions about events. What if that storm track had made landfall a little bit further south? And questions about how impacts are felt in communities. How is risk distributed over different residential groups in the community, different income classes, different social vulnerability? And the idea is that these questions are input into a user interface that can be done by people without any modeling background. And they're broken up into three ingredients: a projection about the future, economic growth, sea level rise, an event, a weather event like a heavy rainfall event, a king tide, a hurricane, or any combination, and a strategy, things you can do in your community to try to reduce your flood risk, floodproofing, home elevations, seawalls, pumps, etc. And what happens when you enter that information into the interface is it goes into a backend that does a lot of work for you. It's connected to two models. They're both open source free models. Sphinx is a physics-based compound flood model that is extremely rapid, and Delphiad is a rapid flood impact assessment tool. Both of these are running in, for kind of county scale order of 1 or 2 minutes. So you get your scenario results rather fast. And what happens is it makes the changes to these models that represent what you've put as your scenario into the interface, and then it runs the models and it outputs useful information, flood maps, impact maps, and also summary metrics about the scenario that you're evaluating. So this is the idea, to bring modeling advances to everyone. So people at city offices who want to explore different scenarios. So here's a question we get a lot. There's so many tools out there. What makes FloodAdapt unique? So we want to take a minute to tell you the things that we think are unique about FloodAdapt and why they help fill a gap in the planning process right now. So the first thing is that you can actually simulate meaningful events that connect with community members. So these are a couple of examples. We've been piloting FloodAdapt in Charleston. So last year in 2022, Hurricane Ian was projected to make landfall in a very unfavorable location for Charleston, but it did migrate and they were largely spared. So you see this headline, Charleston was spared by just 20 or 25 miles. That's a situation that really resonates with community members. Another recent event was in 2021. There were high king tides in November and many roads flooded. And this was also something that really is in the public consciousness. So these are events you can simulate and you can say, hey, what if this had happened in the future with sea level rise? Or what if there'd been more people living in the area? And it's more meaningful than just your kind of standard return period events that most community members will not understand or resonate with. Another thing that makes FloodAdapt unique is that you can actually specify actions interactively that you can take and evaluate the effectiveness of them. So you see here a couple of examples. I'll go ahead and click on them. So over here on the right, I'm drawing in a flood wall. On the left, I'm zooming in and I'm going to select some homes that are in that impact model to elevate. So you can see here, just click, 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 clicking around and making a flood wall. Over here, just clicking a polygon around the homes I want to elevate. And then you can enter a name. You enter how high you want that flood wall to be or how high you want to elevate those homes, either above datum or above base flood elevation. And it's as easy as that. Your measure is now logged into the system and you can run many different simulations, for different events and different future conditions with those measures in place. So another thing that makes FloodAdapt unique is that nothing is pre-cooked and the models that are running behind the scene are really state-of-the-art models. So there's been some publications about these, how they work. And this is brought to end users without any modeling background. So that's really something we think is unique, is essentially empowering city staff and similar types of users to play the role of modeler without needing that background. And the last one I want to mention that we think is unique and really important is that FloodAdapt has made strides towards including recent advances in how to calculate equitable impacts among communities. So what you see here is a utility curve. This is the concept behind equity methods. It's the idea that when you're in the high expendable income range and you lose a little bit of that income, let's say because your home is damaged, if you're earning $150,000 a year and you have $10,000 of damage, the impact on your well-being is going to be much smaller than that exact same loss if you're earning $50,000 or $30,000 a year. So this concept is what's behind a lot of these methods on equity. And what we've done is we've connected the output of the damage model with an equity module that essentially encodes methods in recent literature, pulling in information from the census on income and returning equity weighted damages instead of just pure damages, taking into account this difference in income. So for example, what you see here are expected annual damages. That's your metric for risk, flood risk. And here you see the distribution over the city. If you click equity weighted, what happens is that profile changes. The areas that had high impacts but were also high income are weighted less heavily than those that have lower income with similar impacts. So that's something that we think is really unique. Another aspect that's brought into FloodAdapt related to equity and social vulnerability is that we can overlay any social vulnerability index map over the area of interest, and the homes are tagged with the social vulnerability for the area where they are located. And what this means is that when we run a flood simulation, we can actually look at the results and identify how much of the impacted population is actually of a high social vulnerability. This helps if you're evaluating different measures and you want to know who is benefiting from these measures or who is going to be more at risk under future conditions. All right, so what I want to do now is give a very brief demonstration using this situation that happened last year with Hurricane Ian. So we'll pick up this question over here. What would have happened if Ian had made landfall further south? So what you see here is a window in which I can add an event, I can add a hurricane. Automatically, a hurricane database is loaded. I choose Ian from the list, and it's automatically loaded in my window. And so you can see all kinds of information. You can see the wind and pressure fields all throughout the entire history of the track. And you see when you zoom in that it landed on the favorable side of Charleston here. But with this horizontal translation, I can simply put in -25 and you see the track shift. I can also look at different amounts of shift. For example, shifting 70 miles would be even more unfavorable. And all I have to do then is just give it a name. You can give it any description you want. And when you click OK, this hurricane is added to your event set. There's all different types of events you can define, but it's as easy as that. You can now run this simulation without having to do any additional work. So this is making it very accessible for non-modelers to be able to evaluate a what-if scenario about an event. So I ran this scenario, and what I want to do is just show you how you look at the results in the FloodAdapt user interface. So you can see I'm in a comparison tab here. And when I slide, what you're seeing on the right is the case of the 70-mile shift. And when I come back over, you see the situation as it was. And here you're seeing a heat map of damages. You can see how incredibly impactful that small shift would have been for the city. Now, as you zoom in, these heat maps, they turn into individual building damages. You can try to understand where the impacts are coming from. But the heat map makes that possible at a zoomed out scale, which is very handy. You can also see aggregated damages and road flooding, but that's not shown in this video. In the Output tab, you can select any of your measures and you see an infographic. It shows you how many buildings were impacted for different building types, and it shows you the degree of damage. All of this is configurable, so in your community, you can define the levels that you're interested in. It also shows you people who are flooded and displaced based on destroyed buildings and the fraction that are of high social vulnerability. The other thing it shows you in this compare table tab is you can actually compare lots of interesting metrics about the scenarios. So here I'll just zoom in a little bit. And what you see here are things like building damage, number of flooded homes with high social vulnerability, flooded businesses, and there's a bunch more of these. These are also configurable. You can determine the metrics you want to see in the user interface yourself. So here you see the differences for these different hurricane landfall locations. So that's the demonstration that I'm going to show. In terms of what else FloodAdapt can evaluate, there's a lot. So here I'm going to summarize the different things I didn't show in this demonstration. So we talked about the different drivers of risk. You can evaluate all of these in FloodAdapt. So we could have done the same hurricane with sea level rise or population growth. You can also run a lot of types of events. Rainfall, surge, tide, wind, and river discharge can all be simulated by the underlying Sphinx model. You can choose historic events, pulling data from NOAA gauges automatically. You can do hurricanes like I showed you. You can do any synthetic events. You can come up with any what-if event yourself, or you can put in a set of events if you want to do probabilistic risk analysis and calculate those return period flood maps that we're all familiar with. In terms of strategies, you can calculate flood walls and levees, pumps, urban green infrastructure, flood proofing, buyouts, and home elevations. Those can all be selected through the user interface. It also calculates risk, as I mentioned. It runs many different flood events with known probabilities, and it integrates all that information into return period flood maps and risk. Then you get an output infometric that looks like this. You get your expected annual damages. You get information that's more meaningful to community members, like how many homes have a high chance of being flooded in a 30-year period. This is configurable in terms of what you consider a high chance and the period that you're interested in. And then for each of the return period events, it shows the number of homes impacted and the fraction that are high social vulnerability. I've shown you the equity weighted risk. It also does benefit calculation, and this is very useful for being extremely transparent and reproducible. What it does is it calculates the risk reduction benefits today under current conditions and the risk reduction benefits of your measure in the future. It then interpolates this to get the annual risk reduction benefits and applies a discount rate, which you are free to choose yourself. And there it calculates the discounted benefits per year, and then it integrates these all to get the current value of your benefits. If you have cost information, it will also calculate a benefit cost ratio for you. It also helps navigate you in which scenarios you need to run in order to evaluate your measure. So that's what FloodAdapt does right now. Some things that are on the cooker for future developments, just as a teaser, are making it more accessible and suited for inland communities who are dealing with river flooding. Also including urban drainage infrastructure, which is also important in terms of helping to alleviate some of the flood risk. That's something we're looking at it for future development. We're looking at including network models that can tell something about accessibility when roads are flooded. This is an impact that's really important in terms of evacuation or being able to reach important critical facilities like hospitals. We're thinking about including waves, which would allow us to evaluate the effectiveness of coastal nature-based solutions like salt marshes or mangroves or coral reefs. We'd like to go further with the equity analysis and inclusion of social vulnerability data and making more use of technology, cloud computing, parallel computing, making things faster and easier and more accessible. So that is the overview of FloodAdapt. I've put my contact information on this slide. So if you're interested in more information, please do reach out. We are planning to release FloodAdapt in 2024. It is an open source tool. It is free to use. So the idea of FloodAdapt is to make it as accessible as possible to help people improve their adaptation planning, better connect with communities, and accelerate the process of preparing for the future. Thank you.